one of the big uses for the laws of logs is to solve an exponential equation. So up until now, we've had to solve exponential equations by graphing y1 equals, whatever, say 2 to the x, and y2 equals 5, and say what value of x gives you a 5, right? Like what's the exponent? So what's a logarithm? It's an exponent. All together, ready? On 3. What's a logarithm?
An exponent.
An exponent. I do good with that. When we do, what's the topic? It's mutually, when we do mutually exclusive, make sure you understand that, because last semester they scored like 14% on that question. So that's not good. Either like I taught the entire thing wrong, or they just asked some really weird question. On sinusoidal, where the province averaged about 50, my class average on those questions was like 76. So sinusoidal, good job. Mutually exclusive, not so good. Okay, money problems is one place where you can use.
I have money problems.
Yeah, so do I. See that car? I gotta pay for that. Oh, you should see the electric
Are you
roller.
going to teach us how to solve money problems?
Yeah, the electric roller skates are at home charging.
Maybe we should buy less posters.
Yeah. No, these aren't. These are like they strap on. They're strap on skates. But they have 50-watt brushless motors, right? Lithium-ion battery pack. 12 miles per hour, which is what, about 18 kilometers an hour. 2-hour battery life. Then there's the electric bike. All right, so we have $800 to put into a GIC. What's a GIC?
Government investment.
Oh, it's called a guaranteed investment certificate, right? So you can buy it from the bank, and what they'll do is say, we will guarantee you a certain interest rate, right? As long as you put it in for a certain term, right? So banks like that stuff. It's like if you take out a 5-year mortgage on a house, then they know that every month you are going to make this payment, right? So they know that there's this much money coming in. And where do they make their money? They take the money that you and I deposit and put into a bank account, and they loan it to other people to buy stuff, and then those people pay. So they pay us an extraordinarily small amount of interest, and they charge them a comparatively very large amount of interest, and that's where they make their money, right? It's in the difference between. So in a GIC, if you say, hey, look, I've got $800 that I'm willing to put away for a number of years, so I'm just going to leave it there, right? So they know you're not going to take the money out, so they'll pay you more interest, right? Because they know they have that money available. So let's say we get an interest rate of 1.8% per annum. So that's going to come out as /A, right? Which means per annum, which is per year, right? Latin annual, blah, blah, here, per year. And it's compounded monthly. This is where we need a little bit of work on the compounding, so that one quiz, which if you remind me, I'll hand you back those quizzes. So compounded monthly. How long will it take? How long will it take for the money to at least triple in value? Okay, so we tend to write these questions so that when you solve it, you've got to take it up to the nearest month, right? It's always going to go up. Because if we solve this and get, say, 17.1 months, then we know that it's more than 17 months, so it has to be 18. And we say at least triple, not exactly triple, because exactly triple would be somewhere in the middle of a month or something. Or 3 days in, or 3 days from the end of the month. So we're going to say at least triple in value. Okay, so the formula you don't get on your formula sheet, right, is the compound interest formula. So we're going to use the formula A is equal to P times 1 plus I to the n. So P is the principal. Okay, which is the amount that you invested. Or the guy that sits in the big office downstairs. Amount invested. Because they're actually spelled the same, right? Principal. There's principles, right? Like, be kind to animals. A is the amount at the end, so the amount you end up with. I is the interest rate per compounding period, right? Which in our case, what's the compounding period measured in?
Did I leave my hoodie in here?
I didn't look around.
I don't.
Anybody find a hoodie? Check back in the fire room.
Okay, thank you.
Random events just seem to happen. What's that? There you, yeah, no, it's just audio, right? All that's recorded. If you ever watched any of these. Yeah. Yeah. I look. Number of views, 0. Number of views, 0. Number of views, 0. It's okay. I'm not going to make any money off the video. That's fine. That's not what it's about. Although, yeah, if you guys would start watching them, then good things. I could pay for the electric roller skates. Actually, the dollar didn't suck as badly as it does now when I bought them, so it really wasn't that bad. Anyways, principal. So that's the amount of money. How much are we investing? Yeah, it says up there. $800. How much do we want to end up with?
1,700.
Big problems if these triple of 800 means 1,700 to you, but more. So we're going to say, I want to end up with $2,400. I have invested $800. What is an expression for, I don't want the value because that's too hard to work out. What's an expression for, so I got 1 plus. What's an expression for the interest rate that we're going to use? So it's per compounding period. So how much interest are we getting? 1.8%. We don't use percents, we use decimals, right? So I guess I should write in here as a decimal. As a decimal. So what's 1.8% as a decimal? Good job. 0.018, right? Because yeah, a lot of people just write like 0.18 and all of a sudden it's 18%. So 0.018. But that's per year, and we are paying interest or getting interest how often?
Per month.
Per month. So what do we do with the interest rate? Divide by 12. Now, if I put an n up there, what time units are used for n? It will be the number of compounding periods, which is the number of months. Okay? So I don't have to put like a 12 in there or anything like that, right? We're just going to solve for n, and we're going to realize that will be the number of months, which is really what we want, right? It's like how long will it take? Well, we're probably going to express that in months. Okay, so up until now, we would have graphed y1 is 2,400, y2 is 800 times this to the power of n. Looked for the intersection, well, we would have said to the power of x. Looked for the intersection, found the x value. Here's what logs lets us do. So first, I'm going to divide both sides by 800, right? Just simplify. So 2,400 divided by 800 is 3. Well, we want the money to triple, right? Because now it's as if we started with $1, we get $3. Because this amount is now really just 1, right? 800 divided by 800 is 1. If I work this out, it's 1.0015 to the power of n. Okay, so I'll let my calculator do that, right? I'm just going to write 1 plus 0.018 divided by 12, hit enter, calculator's going to return 1.0015. Do not round this value, right? You've got to carry out whatever's there. Here's where logs comes in, right? So right now, again, if I asked you to solve this, you graph y1 is 3, y2 is 1.0015 to the x. You'd have to play with the window and adjust it, and eventually find where these two lines meet. But we can take the log of both sides. So we could say log 3 is equal to log of 1.0015 to the n. Now, log 3 is just a number, right? What number is log 3? What's a log? An exponent. So it's the exponent I'm going to raise the base. What's the base of this log? 10. So log 3 is 10 to the power of something, which will give me 3. Right? So we know it's between 0 and 1. 10 to the 0 is 1. 10 to the 1 is 10. And it's closer to 0 than it is. It doesn't matter. We don't need that number, right? It's not like we need it. Now, the log thing says, if this is up here, what can I do with it? The law of logs says this can go here. So now we can write log 3 is equal to n times log 1.0015. No more exponent. Right? So we can solve for n. What do we do to get n by itself? Divide both sides. So n is log 3 divided by log 1.0015. Now it's a calculator exercise, right? You're just going to punch log 3, close parenthesis, divided by log. And you can go 1 plus 0.018 divided by 12, right, if you didn't work that out. Or you can go 1.0015. So you go log 3 divided by log 1.0015. And what do you get? So give it to me like 1 or 2 decimals. How much? 732.
0.957.
0.957. Dot, 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 dot. So how many months?
733 months.
733 months. Now, generally speaking, the way that we try and write the diploma is so that when you round this, you're just going to use normal rounding. Okay. But if this came out 732.1, how many months? 733. You still got to go up a month, right? So anything below 732.957 is going to give us an amount under 2,400. Maybe not much under, but it'll still be under. Anything above this, and we want months, so 733 will give us a number above 2,400, and we want the money to at least triple. Okay, so it will take. Okay, and remember our n value is number of compounding periods, which for us is months, right? Compounded monthly is the number of months. So if you divide that by 12, how many years? It will take. So good luck with that. 733 months for the money to triple.
That's terrible.
I know, eh? But that's kind of the interest rate you get nowadays, right? Like it's just not high. But they don't charge high interest either, so you know it balances out a bit. Here's an interesting, somewhat off-topic question, but let's say 1,000 years ago, you had an ancestor who took 1 penny, put it in the bank at 4% interest per year, compounded annually, right? So you got 1 penny, it's getting 4% interest a year, and for 1,000 years. How much will that be worth? So you are now standing there in a position and saying, hey, I get to I now get this money, because they said, like my 40th, whatever generation, or 1,000 years from now, I want you to give money to whoever's left alive in my family. Okay, so how much money would you get? So what would 1 penny, so this is just an N aside. A fun aside, yeah. Fun aside is better than. Okay, so how much money do you think you're gonna have? Just throw it a guess. Don't work it out yet. Just throw it a guess. How much money do you have? Like $1, $100, $1,000, $1 million? How much? 1 cent. So $0.01, right? We'll do this in dollars when we work it out. $0.01, 4% interest a year, right? And we're going to assume that when they calculate interest, they give you the fractions of a cent, right? So 4% interest a year for 1,000 years. So we know it took, at 1.8%, it took 61 years for my $800 to triple. So how much money do you think you'll have? Just throw out a number, it doesn't matter, it's just a guess.
$12.
$12.
35 cents.
Anybody else? We got $12.
1,000.
$1,000.
Said it doesn't matter.
Anyone else? $100?
2 billion, you said.
$2 billion.
However much like electric
I want that.
Huh?
I want the BD.
You want 2 billion to be the answer? Okay. Got your calculators? So the amount. So our principal. So we're going to do this in dollars, right? So 0.01. 1 penny is $0.01. 1.04. Okay, we're not messing with compounding periods, just annually for 1,000 years. So, what's the amount? How much do we end up with? Anybody got an underflow? Anybody got a number? So 0.01 bracket 1.04 bracket
1 times 10 to the 15.
1 time one what?
1.079.
1.079 times 10. Okay, so 10 to the 9th is what? That's your billion, right? 2 billion. 10 to the 12th. So what's 1,000 billion? What do we call that?
1,000 trillion.
A trillion. I think the Brits call it a little bit different. So 10 to the 12th is a trillion. So this is 1,000 trillion dollars.
Is that penny? Oh,
From
no.
that 1 penny, right? But it's 1,000 years. So 1,000, you know. So you know what an x. So here's the exponential. You know, if we graphed that, what would it look like? So here, do this. Do it to 100. So just go sec function enter, pull a 0 off the end. After 100 years, what's your penny worth?
Less than what? 0.5?
0.5. 50 cents. 100 years to go from 1 penny to 50 cents.
What?
So what if you did 200 years?
So you're getting less.
Sec function enter. Well, you get less than you're getting 1,000 years. $25.
Holy shit.
So if you graph this, it looks like this, right? Like if you graph this, so 10 to the 15th is actually on the scale, then, you know, $25 and $50, nothing. You're seeing this.
Flatline.
And then it does that.
What the hell?
Right? That's an exponential function, right? Like it starts out low and slow. Not much happens. When it takes off, it takes off. Right? Like what's 500 years then? So do
3,286,000.
Okay, so 3 million. Right? That's half. We're halfway there. You got 3 million, right? And then in another 500 years, that goes from 3 million to more money than there is sitting in the world today, right? Like there just isn't that much money around. Period.
That's okay.
Okay, so that's just an interesting aside. It's the power of compound interest, right? That's why if you can actually get interest rate, like not 1.8%, but get a decent interest rate, and if you put your money away, because the thing you have on your side right now is you're young. So if you have a job, if you put some money into an RRSP or something and invest in a mutual fund that goes up in value, you can have a reasonable amount of money by the time you're ready to retire. Not just triple, right? Talking like, 10 or 15 times the amount of money. So you might have that. Then you can buy those electric skates. Okay, so how do we solve something like 4 to the power of x plus 2 is 75? So the way to solve for an unknown exponent is to take the log of both sides. So we write log is equal to log 75. Remember, log is just it's just a function, right? It just says, well, instead of 75, give me the power that I would raise 10 to get 75. and do that on the other side. As long as you do the same operation on both sides, you're maintaining equality, right? It's like I could square both sides, I could square root both sides, right? They would still stay equal. Now we bring the exponent down, right? This is the power of using logs to solve this, is I can bring the x plus 2 down. When I do, though, it has to be in parentheses, right? Because remember, it's an x plus 2. If x is 5, that's a 7. If x is 9, that's an 11. There's no way it's that, right? I mean, it's like 4 cubed is 64, so it's just a little bit over 3. So x is like 1 point something, right? But if you do this, if you write this, x plus 2 log 4, then what you're saying is, okay, take this, multiply it by 2, and that add. We don't want that, right? We're saying it's this quantity, x plus 2, which has to multiply the log 4. And will end up being equal to log 75. Okay, we want to solve for x. What's the first step?
Get it out of the
So you could expand the brackets, but you could also just divide both sides by log 4, right? Because that'll isolate the x plus 2. So we'd say, all right, well, x plus 2 will equal log 75. What's log 75? It's an exponent, right? It's just a number. What number? It's the number that you go 10 to the power of to give you 75. What's that number? I don't care. Calculator knows that. I don't need to know that. I know it's less than 2. Bigger than 1, it's closer to whatever. Okay, so what's x equal to? I want to isolate. I want to write x equals. So how do I get rid of the plus 2?
minus.
Minus 2. So we'll go log 75 divided by log 4 minus 2. So, to 2 decimals, what's x? 1 point. 1 point, sorry. 1.11. You want to check that. What are you going to do? You'll go 4 to the power of 3.11. What are you going to see? 75? Not likely. Something close to 75? Likely. How close is it? So, what's 4 to the power of 3.11? 74, close enough, right? If you want the exact value, if you go 4 to, you can't now if you did that, but if you've got the 1.11 etc. sitting there, if you go 4 to the power of bracket answer plus 2 bracket, you will get exactly 75, right? Because you're putting in like 10 decimal places worth of answer. Okay. So on the test, if it's numeric response is to the nearest hundredth, just understand that, yeah, I'm going to get something close to 75. So if I get like 750, it's like, yeah, I made a mistake. If I get like 42, yeah, I made a mistake. But it should be close to 75. What's next? It's blank. 3 to the, oh, here we go. So 3. So 3 to the power of x plus 2 is equal to 7 to the power of x minus 1. Now, what they could ask you in this is just basically saying, so-and-so is going to solve this problem. Where did they make the mistake? Okay? They won't ask you to solve this. And if I were doing this on the diploma, I would do it graphically. If I had to work out x, I would just graph y1 is 3 to the x plus 2, y2 is 7 to the x minus 1, because that's a heck of a lot easier than what you're about to see. And now, this is what you're about to see, right? And I would practice like one of these. Maybe there's one in the book. Like, just do one, just, you know, for the sake of doing it. So we take the log of both sides. So that's where we start, right? So that should be step 1. Step 2 is we're going to pull the exponent and put it where? Out front. And what are we going to do with it when we write it out front?
Brackets.
We're going to put brackets, yeah, parentheses, right? So it's going to be x plus 2 log 3 is equal to brackets, right? Yeah. Did that on purpose, just so you know. I know how to do this stuff. I still make mistakes, but that one. Okay, now comes the depressing part, right? in order to solve this, we need to get the x's together on one side, right? Because we're solving for x. So in the last one, we could just say, hey, divide both sides by log 4, because the x was only in one place, right? Here, there's x's in two places. So we need to expand this and get x log 3 plus 2 log 3 is equal to x log 7 minus log 7. Okay? Now remember, if you're looking at this type of question on the poem, you're more or less looking at, here's a solution, where do they make the mistake? You know, now it seems to be in step 1 or 2. It's often in step 3 or 4, right? Nowadays I'm seeing it in step 1 or 2, but you need to actually find it. Okay, if you have to guess, I don't know, guess 1 or 2. We had a 20-1 test the other day where it was step 1. I said, do you really want it to be here? Yeah, I really want it. Okay. Okay, so now, here's what we're going to do. We got x log 3. I'm going to move this over. So it's going to be minus x log 7. So I need to get all the x's together on one side. And I need to move this 2 log 3 over here. So it'll be negative 2 log 3 minus log 7. Or negative log 7 minus 2 log 3, right? Either way, you'll see the same two terms. You'll see the 2 log 3 and the 7 both will have a negative in front. Now, we factor the x out of this expression. It's on a quiz. I might ask you to do one of these, and probably not. Yeah. Now, how do we get x by itself?
Divide both sides.
Divide both sides by log 3 minus log 7. So what we needed to do was expand it, right? I have an x on each side, so we need to expand it. We need to get the x's on one side of the equation, and anything that doesn't have an x on the other side of the equation. We then factor the x out of the side that has the x's, and then we divide both sides. So x is equal to negative 2 log 3 minus log 7 over log 3 minus log 7. Okay? You can't do any canceling there. You just have to work it out. So if we actually want a value for this, I would go bracket negative 2 times log 3, for instance, minus log 7. I'd probably hit enter at that point. Just work out the numerator. Then go divided by bracket log 3 minus log 7 bracket. Or bracket negative 2 log 3 minus log 7 bracket divided by bracket, and then the bottom expression. Right? Or maybe it's just left in that form, right? So what they could ask you also is, given this and the first few steps, the answer is, and then give you four potential answers in that form, right? But they would start you out with a couple of steps, probably. Okay. Oh, and if you work out the answer and you want to check it, then just take your x, but just go 3 to the power of x plus 2 and go 7 to the power of whatever your number is minus 1.
What's the end?
I don't really care. This is the answer. Yeah, what it works out to, that's a calculator exercise, who cares?
Because like the brackets are.
Yeah, it's important that you, I don't know, let's work it out. Where's the wabbit? That looks like, that's like in front of my house. There's like 7 of those guys each morning just sitting in the park. And they're all white because it's supposed to still be white out, right? It's like, hey, good camouflage, guys. Okay, let me get out of that. Okay, so we do this. Bracket, negative 2 log 3, bracket, minus log 7, bracket, divided by bracket,
What?
log 3, bracket, minus log 7, bracket. Enter. 4.8898.
Dang it.
Okay. So if I store that in x, so if I say, hey, put that into x. Okay. So what I said was store, STO, and I said store it in x. So now what I can do is go back to the original problem, which was what? 3 to the power of x plus 2, so I can go 3 to the power of bracket x plus 2, bracket, enter. And I can go 7 to the power of x minus 1. And what do I expect to see? 1937.6706. Okay? If you went 3 to the power of 4.9 plus 2, so call that 6.9. And if you went 7 to the power of, whoops, you went 7, clear, 7, give me, quick. All it's doing is writing. 7 to the power of, so I said 4.9 be 3.9. Then they're going to come out close, right? But that's rounding the nearest tenth, so they're close. They're in the same ballpark. And if I want to see full accuracy on it, then I just need to carry more decimals. The more decimals I carry, the closer they will be to each other. All right, 1, 2, 3, 4, 5, 6, 7, 8. In 1986, there was a nuclear accident at Chernobyl.
Really?
Yes. It contaminated the atmosphere with radioactive iodine-131. Okay, so I'm just going to kind of summarize this. 1986, Chernobyl nuclear accident.
Where was this?
In Chernobyl. It's in the Ukraine, I think. Were they still there in 86? Radioactive iodine 131. So when the Fukushima reactor had its problems, that's the one in Japan, which happened in your lifetime, during your lifetime, not that long ago, right? What they do is they give iodine to the population, right? Because your thyroid gland uses iodine, right? It takes in iodine. If you don't give it iodine that's uncontaminated, you will take in contaminated iodine. You don't really want thyroid gland cancer, so they'll distribute iodine in the population, which means your thyroid will take in that iodine, and then any other iodine that comes in won't need it, right? So it won't absorb the radioactive iodine. So, anyways, they do that. It took 45.7 days, so 45.7 days for the level of radiation, for level of radiation to drop from 100 units to 2 units. Determine the half-life of radioactive iodine-131. So determine the half-life. So what's a half-life?
Time it takes for the thing to undergo half reaction.
Yeah, so if we started with 100 units, so there's 100 units in the atmosphere, the half-life, after one half-life, we would have 50 units. After another half-life, we would have how many units?
25.
25. Then 12.5. Then 6.25. Then 3.125. Right, so that's going to happen. Now, if they're going to ask you a question like this, they're going to give you an equation to work with. And the equation is, or use the formula, so A is equal to A naught. That's just using the British for 0. Right? They call them knots. 1/2 to the power of T over H. And if they're going to give you that formula, because it's not on your formula sheet, it's going to be a big box explaining everything about the formula, right? So A naught, or A sub 0, is the initial amount. This is really kind of like a compound interest formula, right? I mean, there's a base. It's an exponential formula, right? It's got a base, got an exponent, it's got an initial value, it's got a final value. So A naught is the initial value, A is the final value, final amount or final value. T is the amount of time, and H is the half-life. Okay, so what do we know? How many units did we end up with? 2. How many did we start with?
100.
How much time did it take for that to happen?
45.4 days.
And what's the half-life? We don't know. So we're going to use H, right? Because we don't know. That's what we have to work out. So, right, formulas there. You can have this big context box at the top because they use following information to answer the next question. Chernobyl, blah, blah, blah. Units, blah, blah, blah. Use the formula to determine the well, they won't say determine, right? To use the formula and express the half-life rounded to the nearest hundredth or something of a day, right? It's got to be in the same unit. So T and H need to be in the same unit. I think the one time they tried that on an exam, they had to throw the question out, right? Because they use different units, just like nobody got it, right? So, exactly. Why did they throw that question? I think we used hours and we used minutes, and yeah, nobody got it. So. Okay, so we want to solve for this, right? What's your first step? Divide both sides by 100, right? Okay, if we simplify, right, what are we trying to solve for? H. Where's the H? It's up there in the exponent. How do we solve for exponents? We've got to use logs. How do we use logs? We can't have numbers in front. Okay? You cannot take the log of 100 times 1/2 to the 45.7 over 8. That's not true. You can, but you can't. Like 30-1s have problems with that, right? Like they'll mess it up. So there is a way to do it. We're not going to learn that. We're just going to say, hey, get rid of the 100. So this will be 1 over 50, right? You divide both sides by 100, get 1 over 50 is 1/2 to 45.7 over 8. Okay, so no number in front. We can take the log of a base to an exponent, but it's got to be a lone base with an exponent. Now we can do log. So we're going to log both sides. The log of 1/50th, which is just a number, right? You can plug that in your calculator, get the number. I'm not interested in it. I don't want to know it. And log of, and then we've got an expression, 1/2 to the 45.7 over h. So what do we do with the log of 1/50th? Nothing, we just leave it, right? Oh, maybe we write it as the log of 0.02. So we don't have to mess with fractions. So maybe you just went 2 divided by 100 got 0.02. She's in 0.02. What do we do with the right side? What do we write?
0.5.
So what do we do with the exponent? Bring it down in front. When we do, put brackets around it, right? Because it's not really, you know, it needs to be treated as an expression, right? Which we're going to solve for. Times the log of, yeah, 0.5, right? 1/2 or 0.5. This is good. I see a higher average this term in 30-2. Okay. I can sense that. Last average was 68.9 or something, I think. Provincial average is 59. Yeah. Yeah, you guys will beat provincial average by 10. We pretty much always do. At least 10.
We're intellectually.
Yes, you are just intellectually superior to the people that are out
We're better
there. Okay,
than everyone else.
you're better than everyone else.
We're the superior Americans. The good side of town.
Okay, let's divide both sides by log. We want to get h by itself, so we're going to divide both sides. Or what should we do? You know what? Let's multiply both sides by h. Right? Get rid of this h. So I'll get h times the log of 0.02. Okay, I can hear the average dropping. Okay, Tim, I thought it would just get over 70, and now it's dropped into the 60s. I don't know if it's going back up. It's like, yeah, I know. Yeah, it's a good thing it's not last period. It shouldn't be last period Friday. But, and that was math 31. Right? That was like calculus. You'd think they would be Okay, so what's h? We're going to divide both sides by the log of 0.02, right? So we're going to take 45.7 log of 0.5 divided by the log. Here we talk. I just don't want to hear it. I mean, unless it's like really cool stuff. Okay, then speak louder. Okay, work that out. What do you get for h? Round to the nearest hundredth, let's say. If in doubt, nearest hundredth. You should never be in doubt on a diploma. It will always specify. If they don't specify, then it's a whole number. Delete. Okay, we'll miss you. Round to the nearest hundredth. Give me 2. 8.10. So there's always this argument of, well, so what takes you around nearest hundredth and works out to 8.10? What if you only bubble in 8.1 and you don't bubble in the 0?
Wait, what was the question?
They're still going to give you the mark.
Oh, good.
What if you ignore everything we've been telling you for the last 3 years? The answer is 2, and you bubble in blank, blank, blank 2. Still going to give you the mark.
Who?
No, they do.
What happened?
So here, they'll give you the mark. Like, actually, so if the answer is 2, and you go 2, blank, 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 you get the mark. You go blank, 2, blank, blank, you'll get the mark. You go blank, blank, 2, blank, you'll get the mark. You go blank, 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 2, you'll get the mark.
What if you do blank, 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 blank?
Then you won't get the mark. Did that question really need to be asked? However, just bubble correctly. We start at the left, we go to the right, and we leave blank. So if the answer is 17, it's 1, 7, blank, blank. Okay. Anyways, I'll give you a chance for that, because when we do the midterm, which will be like the Tuesday after spring break, I will give you a scan sheet to fill in that looks a lot like the scan sheet you'll be filling in. So it'll be multiple choice and numeric response. And you have to bubble them, right? I know we give you a test now and we say bubble them, but we're actually just looking at them and marking them. I'm going to give you one that actually gets scanned in by machine, it gets PDF, it gets compared against the answer key and marked. So you do actually have to bubble or it won't give you the mark. Okay? All right, next. Okay, here's one. So over the last 10 years, the amount of money in billions of dollars, we're talking real money, not penny after 1,000 years money, but still real money, spent in North America by car dealerships advertising their product can be modeled by. So money, I'm just going to summarize this, M, billions of dollars. Equation, M is equal to 0.15 e to the power of 0.3 t plus 0.78. Okay, so that's the equation. If you go on and you do post-secondary and anything, marketing, biology, whatever, you're going to see e pop up a lot as the base, right? So instead of saying 10 to the power of, we say e. Okay, they use that, that's the ln, right? So you've got log, right? So log is 10 to the x, right? Like 10 to the x gives you log, you convert to exponential to logarithmic. E as a base gives you ln. Okay, now we got to explain what stuff is. So where t is time in years after 2000. So t, time in years after 2000. And M is the money in billions. So when will they spend $3 billion in advertising? What year will $3 billion be spent? I hear the marks rising now. I think we're up over 70 again. So what year will $3 billion be spent? So what are we going to do? Where we see M, we're going to put what? 3. Just 3, right? Because M is in billions. Okay, I got to isolate that e to the 0.3 t, right? T is what we're trying to solve. We're going to get t by itself, or as close to by itself. Step 1, do what? Subtract the 0.78 from both sides, right? So what's that give you? 2.22? Yep. Okay, next step.
Put the T down. Or
Got to get rid of that 0.15. How? Divide both sides by 0.15. Okay, so we have 14.8 is equal to e to the power of 0.3t. We're trying to solve for an unknown exponent. How do we do that? We take the log of both sides, but this has e, so what we're going to do is take the ln of both sides. So we'll say ln of 14.8 is equal to ln of e to the 0.3t. Okay, so ln is just like log, right? As far as you're concerned, it's just a key on your calculator. It's going to give you a number. A log or a ln is an exponent. In this case, the exponent that you're going to raise the base e to instead of the base 10 or the base 2, right? But it's just an exponent, right? It's a number. So what do we do? We do that. I got this exponent. I want to move it. Where do I move it? In front. So it becomes 0.3 t ln e. Okay, want to get t by itself? What are we going to divide both sides by? 0.3 ln e. 0.3 ln e. Ln e's cancel, 0.3's cancel. So I have t is equal to the ln of 14.8 divided by 0.3 ln e. So what's t? To 2 decimals. Because I like 2 decimals. If in doubt, 2 decimals. Now you're just using the ln key, right? So log t. You're going to do this in one step. You're going to have to go ln 14.8 divided by bracket 0.3 ln e. E, it's above. It's above the ln key. It's a second function ln. That I think gives you. Does that give you e to the x?
Yeah.
Yeah. So then just do e to the power of 1. It'll bring you to e. Unless you know that the ln of e is just 1, in which case you just. So the ln of e is just 1. Right? Because the ln is, what do I raise the base e to get e? 1. Okay. But it doesn't matter. You can type in ln of e. It's right. What do you get? 8.98. So in what year, based on this model, remember the model is based upon growth rate has to stay the same, blah, 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 right? Like conditions that were in effect at this time remain. What year?
2009.
Okay, it's really late in 2008. It might be December 30th, but it is in the year 2008. So here's the other rounding kind of thing you got to watch out for. One is to say to at least triple means whatever number we get, we got to round it up to the nearest whatever time measurement we're in, right? So 732.9 months becomes 733. 732.1 months becomes 733. During what year? 8.98 is during 2008. It's like 0.98 of the way through the year. I don't know what that is, right? It's how many days into the year is 0.98. So if I went, turn on. If I went 0.98 times 365, 357 days. So it'd be like December 358, December 26, 27. But it's in 2008, right? We haven't moved to 2009. So trick, this one rounds down because it's still in that year. Don't worry, we won't ask you trick questions. Okay, last one, and this is the, how does my calculator work if I can't get it to, log base 3 of 33. Okay, now, time to pay attention. Okay, I'm not going to say that many times during the year, so when I do, pay attention. Okay, this you need to know. Because you may have a calculator where you have to use this thing, and you may have a calculator where you don't have to. Right? If you got a TI-83, you have to use this. That's what I'm about to show you. How do we work out log base 3 of 33? That's the problem, because we have a log key, we got an ln key, we don't have a log base 3 key. Unless you've got the newer firmware on a newer calculator, then you do. Okay? But you still need to learn this, even if you have that fancy calculator, because we will ask questions which rely upon you knowing what we're about to cover. So, how do I solve this? Here's what you do. You say x is equal to, I want to work this out. I don't know what it is, so I'm going to let it be some variable. Okay, I'm going to let it be x. And now I'm going to say, okay, let's change this from log form to exponent form. So what's the base? 3. What's the exponent? And what's it equal to? Okay, so you got to be able to change from x equals log base 3 of 33. Say, this is the base, that's the exponent, that's the value, right? 3 to the power of x is 33. Okay, how do we solve for an unknown exponent? We take the log of both sides. What do we do with the x? Bring it out front. How do we get x by itself? Divide both sides by log 3. So you want to work out log base 3 of 33? What we do is we need to change the base from base 3, which we may or may not have. I'll show you how to get it if you have it on your calculator in a sec. So we change it from a base 3, which we may or may not have, to a base 10, which we all have. How do we do that? We let it equal something, we change it to exponential form, and then we solve for the exponent. What's the easy way? It's the log of the value divided by the log of the base. Okay? So if I want to work out a base 5 log, and it's log base 5 of 27, I go log 27 divided by log 5. It's on your formula sheet. Okay? It's a little more complicated there. It says log base A of B equals log base B of C over log base B of something, whatever. It's on, what does it say? So on the formula sheet, it looks like this, right? So they give it to you. It's called the base change. They give you log base B of C. Log base B of C is equal to log base A of C over log base A of B. So it's the log of the value divided by the log of the base. Generally, we're going to go with base 10, right? So if you type in log 33 divided by log 3, log 33 divided by log 3, we get 3.182, blah, blah. It makes some sense, right? Because 3 cubed is 27, so it's going to be a little bit more than 3. Here's how you do it on your calculator. If go alpha and window, and you see number 5 is log base. Okay. Now, if nothing happened when you did that, then you better learn how to do this, the thing that's underneath. So I do number 5, log base. So it shows log base, so I say I want base 3 of, and I go into the value and put in 33 and hit enter. Okay? So how many of you have calculators where you can do log base? Okay, so good. I wrote a question based on this for the diploma exam where it doesn't matter if you know that, because what's important is that you know how to get from that to this. Okay, that's what the question was based on. So being able to work out the log base doesn't help you. So you need to know this concept. It uses this formula. Generally speaking, we go to log 10, but try this. What's ln 33 divided by ln 3? So don't do logs, do lns. What's ln 33 divided by ln 3? Exact same number.
Oh my god.
Right? Because it doesn't matter what base log you change to. So I can change to a base E log. Right? This can be a base 10 log, this can be a base E log. Maybe I need to change from log base 333 to log base 5. How do I do that? I go log base 533 divided by log base 53. Okay. I just can't really work those out without a calculator. And all the different ways give you the different answers. Okay, so that's called the base change formula. And some of you are going to have to use